Please welcome our next speaker, Microsoft MVP, Anitha Eswaran. Today, she will be presenting her session on Unleashing the Power of Cloud Data Management. Please stick around after Anitha's session for a live Q&A.
Hello all, I hope you are all doing good. Thanks for joining the session in spite of your busy schedule. Good morning, good afternoon and good evening to everyone here. So today's topic is Unleashing the Power of Cloud Data Management. A quick intro about me. Myself, Anitha Eswaran. I have 18 plus years of experience in Accepta, AX and D365 I started my career in the earlier versions of Accepta. And I am currently residing in the United Kingdom. I author the blog and I also have the newsletter, which I have mentioned in this slide here. So I regularly post my updates and whatever a part of my learning in my newsletter and the blog. Over to our key topic. So introduction to the data management in Azure. So the moment we think about the data management in Azure, what comes to our mind? Obviously, the Azure Data Storage, correct? So the Azure Data Storage is a scalable cloud storage solution offered by Microsoft. And with the additional services, Azure services, what the provider with additional functionality for the data management, we can use the Azure services to retrieve the data and effectively. There are several types of Azure storage to meet the different needs, which I will be telling in the preceding slides. So there are various types of storage. For example, you can store the files in a different storage, in the different blob storage, or you can store the messages, you can store in the tables, and what are the types of information, you will have different types of Azure storage. So what are Azure storage accounts here? Azure storage accounts, they have a unique namespace for each Azure storage. For instance, if I am creating Anitha demo in my subscription, be it in a different region, it cannot be used in any other Azure region at all. Be it is unique across the Azure. So the same name cannot be used again here. And it can be accessed via HTTP or HTTPS across the world with a security. Obviously, since we are dealing with the data, it comes with secure and it is highly available, durable, and massively scalable here. So Azure, the Microsoft takes care of bringing your security and availability, durability, how it is durable, how it is available, that I will be explaining in the coming slides. What are the types of storage accounts we have? We have Blob Storage, which is mainly useful for unstructured data here. Like unstructured data in the sense it can be anything, media, it can be a PDF file or whatever it is, even encrypted data. It comes under the structure unstructured data. So all this falls in Blob Storage. File storage, if you want to manage the file shares and which can be mounted concurrently, then in that case you can use file storage. Queue storage, it is mainly for the message communication, for workflow processing. So that where the receiver and the sender need not be online at the same time. In that case, the queue storage will help you here. The table storage. Table storage is ideal for the structured data. So we are anyway familiar with the table. Since this session is for beginners, table it is constructed of the indexes, entities, all this. So this is mainly for the structured data where the table storage is used. And when you create a storage account, you will start by picking up the type of the storage account. Okay, so this type determines the storage services and the redundancy options and how it will be impacted for your use case. So these are all decided when you create a storage account. So once you create a storage account, then you will be able to identify what type of redundancy you want, what type of services you will be using it. All this you will be deciding when you create a storage account here. Before going on to what the different types of storage account, let us check what is standard and premium storage account. So obviously standard and premium storage accounts, there are slight differences. Let me tell you what are the differences we have. Standard storage accounts, they use magnetic hard disk drives for data storage. And the premium storage, it uses the solid state drives for the data storage. And because here standards, they have the lower cost per GB. And since premium storage is offering the low latency performance, because you can easily retrieve the data when you have the premium storage accounts, obviously that would come with some extra cost, correct? So then standard storage is ideal for the data that is infrequently accessed. So you can use it, so that saves the storage cost here. So whenever there is a data which is infrequently accessed, then you can opt for the standard storage. So, and the premium storage is mainly for the virtual machines with the intensive IO intensive applications like the databases. So in essence, the premium storage is, it combines the feature of the standard storage as well, correct? So if you see that whatever the standard storage is offering for you, even that is also the premium storage is also is having, but on top of that, it has some additional features like it will have a good throughput and high throughput, a low latency. All this can be used using the premium storage. And once you create a storage with either the standard or premium, you cannot interchange after that. For instance, if you create a storage account with the standard type, then you cannot switch on to the premium storage account and vice versa. So in that case, if you want to copy the data, then it is advisable to create a new storage account of your desired type here, either a standard or a premium. So that is based on, then then the data can be moved across the storage accounts here. The only thing is you cannot convert the storage account, the standard storage to premium and the vice versa. Azure Blob Storage. Okay, so this is familiar to everybody. Azure Blob Storage is mainly for the unstructured data. So what is unstructured data here? It is least organized data. So it may not have a clear relationship, and the format of the structure is also called as, and it is a non-relational structure. It is a non-relational data. And here, if you want to access the data, so if you remember in my previous slide, I have told you how the data, the storage account is accessed using the HTTPS or HTTP format, right? So this is how the blob storage is also accessed. HTTPS followed by your storage account name .blob. So here the blob.co.windows.net decides which types of blob storage you are using here. And Blob is not limited to only one type of format. So it can even have a binary data where you have details of any encrypted message or any other application, and even the data in the format and the custom app what you are developing. All these can be stored in the blob storage here. For instance, here I have listed few of them. There are many, but I have picked few of them and listed here. Like you can serve the images or the documents directly to a browser, and you can also store the files for the distributed access. And you can even stream a video or audio, and the storing the data for backup, restore, and disaster recovery and archiving. So all this you can store in the blob storage. And if you see this picture here, this is the account where we'll be creating a storage account, a simple picture here, a container. So usually we'll call it as a folder, but in blob you don't call it as a blob folder, you call it as a blob container. So you create a container as per your requirement, and then you upload the data here. For instance, a container called picture, you will be able to upload the picture, the blob inside the container. For instance, movies or whatever it is, you will be able to do it. Next is the file storage. File storage, it allows to create the file shares without managing the hardware. So here, once you create a file share, you don't need to worry about the operating system, or whether you need to patch the operating system, or whether you need to do a backup. There is no need to worry about it, because that is already taken care by the Azure. So like how the blob storage is accessed, here the storage account for the file is accessed using this HTTPS. So this will be followed by the folder whichever you are creating for this particular file storage. And it will be provide the fully managed file share in the cloud. And obviously, so here the security is a question, right? So here it can be accessed through the application Active Directory or the SaaS token. So obviously the SaaS token, if you share it, it will be only available for a limited time. So once it is expired, then the access is is not possible. And only through a the RBAC control and via the AAD, you will be able to access the file shares in the file storage. And it is also possible to easily lift and shift. Like for instance, you have a file share where it has both application and data, and it is possible to move either one of them as per your requirement. You can either move the application or data, or if you want to move both application and data, it is also possible. So it is an easy lift and shift as operation is possible here. and it is scalable. So even if you want to increase the size of the file storage here, it is possible, and it provides a very good integration support. For instance, if you want to if you want to consume the file using the Logic apps or any other Azure services, then this integration is also possible. It has a backup enabled. So how the redundancy how the backup is enabled, that I will be telling you in the next slides, in coming slides. It is resilient, and even if there is a power outage or any outage in the area in the data center, then it is also possible that there will be a seamless switch in getting the data for the user, and it can be shared across the multiple machines and the applications. The queue storage. The queue storage is mainly optimized for storing high volumes of messages from application components. So, for instance, here it will be passed as a messages here, and the best one best solution, one best advantage here is the sender and the receiver need not be in the same time when retrieving the message. For instance, the sender can drop the message in the queue storage, and the receiver, he can get the message whenever he is available. For instance, based on any recurrence or whatever, based on the event, whenever it is happening, the receiver can retrieve the data from the queue storage. So this is one of the best advantage in the queue storage, because the sender and the receiver need not be at the same time, and that is an asynchronous process here. And like other storages, this is accessed via q.co.windows.net. So the URL remains the same, except that this keywords keeps changing across the different file storages here. This is the cost-effective option for storing the data in the cloud. And the queue storage can be accessed anywhere in the world using the HTTP or HTTPS using this. And here also the security comes into picture here. It is via using the SAS token or the AAD, the RBAC control here. When it is combined with the Azure functions or logic apps, then the integration can also be enabled. Obviously, here, when you are retrieving the data from the message from the queue, you should have some third party here, right? Where the Azure functions or logic apps or the service bus, you can use it to retrieve the data from here. And the table storage. So this is how the blob storage is for the unstructured data. Table storage is for the structured data here, where you have fields and columns, the fields, columns, all this, you call it as a table, correct here. So this is mainly accessing for storing and accessing the unstructured data. And this is how you will be using accessing the table storage using the HTTPS URL. And the NoSQL data store, it accepts the authenticated clause. Even if it is inside or outside the Azure cloud, the NoSQL data store will be able to accept the authenticated calls, obviously. So the authentication, there is no possibility of unauthenticated calls. So via the RBAC or the SAS token, this call is possible. It supports for both hybrid and the cloud solution. So when there is obviously when there is a Azure table storage, you will be able to see the clustered index, right? Because that is how you will be retrieving the data from the table, correct? So using the clustered index, it is possible to easily query the data from the table. If you see the diagram here, for instance, in the table storage, a table is created. In the storage account, the table is created, customers and wine photos. So it is called, each field is called entity here. What is entity? Nothing but the fields. For instance, in the customers, you have the fields called name, email, or address, whatever it is. So these are all called as entity in the table storage. So like this, the data is structured and it is stored in the structured format. So that is why the Azure table storage is mainly for accessing the structured data. So using the clustered index, it is easily possible to retrieve and query the data in whatever format we want. Redundancy. So what is the purpose of redundancy here? Because Azure, whenever there is any outage, we should have some data available for our access, correct? So Azure Storage, it stores multiple copies of data. It is protecting the data from any power for, it can from the planned or unplanned events, such as when you're doing a hardware transition, or when there is a failure in the network, or when there's a power outage, or even when there's a natural disaster, the user should still be able to access the data, correct? So that is how the redundancy comes into picture here. So redundancy in the storage system is important for ensuring the data availability. So there are various types of redundancy in the storage system. Some of the common types are the local redundancy, geo redundancy, and the zone redundancy. So This redundancy would ensure that the storage account meets its availability and the durability targets even when there is an outage. So that is the crux of redundancy concept here. So before we dive into different types of redundancy, just let us know what are all the key terms we have in this redundancy concept. One is data center. So if you see the data center, it is the main physical building block that houses the infra components or security. For instance, you will have a server hardware, or you will have a storage type, you have a high speed networking. All these are defined in the data center. And the Microsoft, it selects the data center based on the location. For instance, it should be in the viability criteria, like based on the customer demand or the proximity of the populated centers. All this, based on this, the data center will be decided. And the Azure geography. So Azure geography means here there is it is representing a border, a boundary, where it can consist of one or more countries, where for instance the one in one geography you will have one or more countries. That is also possible. So here the Azure geography represents a country. It is divided by a boundary here. And then next comes the region. So each geography can have one or more region. So the purpose of region here is we are segregating each to handle the power outage, or in case of unavailability, or in case of any power outage, you should have the regions which will come into act online immediately when one region is off. So that is the purpose of regions here. For instance, each geography can have one more region, right? For instance, US has 6 regions, and Brazil has 1 region. And data center lies within one or more, each region has one or more data center within a parameter here. Availability zones. So availability zones are physically separated data centers within an Azure regions. Like for instance, not all the regions contains the availability zones, but there are few regions which has the availability zone. So when the availability zone in one region, if one availability zone goes down, immediately the other availability zone comes into picture, and then where the data is accessible, or there is no interruption in accessing the data here or the application. Okay, so there are various types of redundancy. One is the locally redundant storage, geo-redundant storage, zone redundant storage, read access geo-redundant storage, geo-zone redundant storage, read access geo-zone redundant storage. The first 3, the locally, geo and zone, are frequently used, and the other ones are based on the setup, based on the requirement. The other 3 will be used here. So what is locally redundant storage? So now, since you are familiar with the term, what is the region, what is data center, then you will be able to understand how to map the storage redundancy to the data center. So what happens during the locally redundant storage? It replicates the data 3 times within the single data center. So here you have a data center. You will have 3 copies of data in this primary region. So there is a primary region. So that will be replicated thrice. This is the purpose of that. This is how the locally redundant storage will be set. By default, when you create a storage account, the locally redundant storage is also enabled. So when you create a storage account, if you want to switch on to the other redundant storage, then you need to select it accordingly. And since it is a default one, it is of lowest cost, and even it has the least durability. And when you will be using this locally redundant storage is when the data can be easily constructed, okay, and when the data is constantly changing, and it is only replicated within a country. For instance, there are few countries where the replication is not allowed across within the other region. So in that case, it is when you need a replication only in that country, then this locally redundant storage is opted. Next is zone redundant storage. So in the zone redundant storage, there will be 3 storage clusters in a single region. So if you see, there is a zone redundant storage. In the availability zone, there will be 3 availability zones. The data is replicated in the 3 availability zones here. So, and here each cluster is physically separated from others, and they have in the own Azure availability zone. For instance, they are all differently separated. They are on a different perimeter, but the data is replicated across the different availability zones here. So for instance, if your availability zone goes down, then immediately availability zone 1 takes care of bringing the data or making the application available to the user. So even that is what. So even when the data will be accessible during the zone unavailability also. And this is for the best performance, and here the latency is very low. Geo-redundant storage. So what happens here is the data is copied 3 times in the primary region and in the secondary region. So there is a primary region and a secondary region, correct? So you are already familiar with the term what are regions. So it is also possible to set for a storage whether there is a possibility of primary region and there is a backup in the secondary region. So this will be enabled. What happens during the zero redundant storage? The copy of data is available in the primary region as well as in the secondary region. So even when there is a regional outage or disaster, there is no chance that the data will be lost or the application is inaccessible. So that is the reason the data is copied 3 times you have 3 copies of data in each region here. And GRS and RAGRS is replicated with the local redundant storage, because here you have a locally redundant. Inside each region, the local redundant storage is used. And how do you update the data in the secondary region? Once the data is updated in the primary region, using the asynchronous method, the data is automatically updated in the secondary region. So here there is a chance when the update is committed to the secondary region, and if there is an outage happens, the secondary region might not have the latest data whatever you have in the primary region. So that minute difference will be there during this redundant storage here. And the geozone redundant storage. So in this case, if you see, the data is replicated in the primary region 3 times in the 3 availability zones, and it is also replicated in the secondary region here. So this would be mainly used during the regional disaster. For instance, when one region completely goes down, then the other region would be available to assist the user with the copy whatever that the secondary region it has. So it has the maximum consistency and the durability, because here the copy immediately happens here. Whatever the data it is done in the primary region, it will also be replicated in the secondary region immediately. So this provides the maximum consistency, durability, and availability. It has the excellent performance, and even it is a best resilience for the disaster recovery. So during the disaster recovery times, this type of redundant storage helps the user to retrieve the data. The last one, read access to data in the secondary region. This is, as the name suggests, it is only providing the read access to the secondary region here. What happens it replicates the data to another physical location in the secondary region. So you have a primary region and the secondary region. So the data is replicated in the secondary region, but you will not be able to do any write access there. You can only retrieve the data. So the data will be readable in the secondary region if the primary region becomes unavailable. So as usual, there will be a seamless shift in the application. The user will not even feel that there is something wrong and there is some outage due to that. There is something, even that seamless shift immediately happens in this case. But only thing, there is the possibility of only read access is there, not possible to write or delete the data as possible here. So which redundancy option would you choose? So it depends on your requirement. So if how the data is replicated in the primary region, or if there are some cases where you want to store the data only in your local region. So in that case, you should go for the locally stored local redundancy option here. So if the data is to be replicated in the secondary region, that is geographically distant. So for instance, that a secondary region is geographically distant from the primary region. So if there is a regional disaster, then the secondary region in the other geography will come into picture here. So in that case, you can go for it. So there are various factors which would help you to decide which redundancy option to choose for you. So if there is if you read only the read access for the secondary region, if the primary region becomes unavailable, because primary region holds the major data, the main data, right? So if you do not want the users to change to modify or delete the data during the disaster recovery time, then in that case, the secondary data, the read access would be helpful for you. So in this case, you need to decide which is the best redundancy option for you to design for your storage account here. Blob storage tiers. So what is the purpose of blob storage tiers? Here, it is mainly, for instance, if you are creating a data in the blob storage. So now the coming topics is mainly will be focusing on the blob storage, not on the rest of the other storage. So the further topics will be on the blob storage going forward. The blob storage mainly it will organize the data based on the attributes like how frequently you are accessing the data or the planned retention period. For instance, when you are uploading a file in the blob storage, that particular file will be accessed or modified when it is created early in its lifetime, or you will keep accessing or modifying the data in that file. or it remains idle in the cloud or rarely used. So these are all the factors. Based on that, which tier you should map the data in yours. And the main other factor is you can balance your storage cost with the access needs, because there are few tiers. I will tell you what are the tiers. So the tiers are that they also play a role in storage cost here. So you need to be sure which is the ideal tier for you to choose here. So the blob storage. So I am in the hot blob. I was discussing the hot blob storage because this is the most cost-effective solution, because here the storage cost is more. So this is best suitable for when the data is frequently accessed in the storage account here. And the next is cool blob storage. So this is the best when the data is accessed infrequently. For instance, if you have the data which are not frequently accessed for at least for 30 days, then it is ideal to move that to the cool blob storage. So this has a lower storage cost, and it is useful for data having the minimum impact on the business. For instance, even if for instance the data for the business, it doesn't need to access frequently. So in that case, you will go for the cool blob storage here. So for that is the purpose of. But make sure this when you try to access the data file in the cool blob storage, the access cost is more. Whereas here the storage cost is less. It is just the opposite to the hot blob storage. For hot blob storage, the storage cost is more, the access cost is less. But in the case of cool blob storage, it is the other way. Next is cold access storage. So for instance, if you are not accessing the file which are for more than 90 days, or it is rarely accessed or modified, then it is best to move that the file to the cold access storage. So this is storing the data that is rarely modified or accessed, and it is for faster retrieval. It is easy to retrieve the file, but it has the higher access cost, contradictory to the hot tier. And it stores the data for at least 90 days. So during the disaster recovery time, the data from the cold storage, usually such data where during the disaster recovery, this cold storage is being used. The archive access storage. So for instance, where there are some documents, some files where we rarely modify, where the business rarely modifies, for instance, the business document or the legal and the regulatory data, all these kinds of files, they don't regularly or rarely modify, correct? So in that case, it is better to have that type of file in the archive access storage, because this has a lower storage cost. But when you try to access this particular file in the archive storage, then the retrieval cost or the access cost is more here. So, but this is for the storage cost, it is less. There are 3 more types of blob types, the blob storage types. So these are all the blob, page blob, and the append blob. So what is blob? So it is mainly efficient for parallel uploading the large amount of data. For instance, if you want to upload the videos, it is also for simultaneous upload of large amount of videos or the images or the audio clips. Then it would be better to go for the blob here. How it is working? Each block has a unique ID here. And it consists of blocks. So as the name says, it consists of blocks here, and each block has a unique ID. And one block can have 50,000 blocks, and it is not necessary that each block inside that 50,000 blocks should be of same size. It can be of different size also. So once all these 50,000 blocks are uploaded, then they are assembled as a single blob here. So that is how the blob works. And here all the insert, replace, delete, and existing block is also possible. So even if you want to insert a new blob or replace or delete the existing blob in this particular blob, that is also possible in this case. Page blob. So page blob is mainly used for random read and write operations here. Like to initialize to create, like you need to initialize a page blob and specify the maximum number of size of the blob. So in that case, the maximum size is terabyte is available, 8 TB is available. So more than that, then it will end up creating a new page blob here. And in this case, add and update is possible, but not delete. And whatever you do a write to the page blob, it is immediately committed to the blob here. And to make here the Azure VMs, which we will be using, right? All those disks are using the page blob here. So whatever the random read on write operations are possible, that is one of the main feature of the page blob here. Append blob. So as the name says, it is where the data is constantly getting appended to the blob. And so usually, what do you think about the append operation? You will be writing the data at the end of the blob, right? So here also the same case. When you do something to any changes to the append block, it will be done on the end of the block. And here it doesn't support the update or read. So it only supports the modification, editing of the blob here. And the maximum size is 4 MB. Immutable storage. So this is one of the feature in the storage here account here. What is immutable storage? So for instance, if you want to store the business critical data in a warm state, what is warm? Write once, read many state. Then you need to then set the storage account as the immutable storage. What is immutable storage here? The data, it cannot be modified or deleted for a specific interval. So for instance, there are some files where some kind of agreement which is only for 1 year. So for 1 year there is no change in that particular file has to be done means, then you can set up as an immutable storage here. So there is no data can be modified or deleted in that. So the one advantage here is it protects the data from any overrides or deletes here. That is the concept of immutable storage. So there are different types. There are two types of policies you can bring on the immutable storage. One is time-based retention policy and the legal hold policy. So in the case of time-based retention policy, whatever the files you have in that particular objects, it cannot be created or read, but you cannot modify or delete it. The read and the creation is possible in the time-based retention policy. And the legal hold policy, until the legal hold is explicitly clear, it is not possible to read or even create, but there is no modification or delete is possible. That is the same. In both the cases, modification or deletion is not possible, but read and create is possible. So the main crux of the immutable storage is addition, the changes or the deletion is not possible. That is the purpose of creating the immutable storage here. So if you see the diagram, there is a container. There is a container where this is having all these blobs, and here the blob retention policy is log time based policy. So here there is no chance of writing or deleting the blob here. You can also only create a blob. And similarly for the legal hold, until the legal hold is explicitly clear, then here that operation is not possible. Lifecycle management of blob. So even in the life cycle, even the blob is having a kind of life cycle. So this is something new to us. It might be something new to us. So for instance, what happens when you create a blob and you need to delete a blob, so that if you manage it properly, that saves the cost. So that is what this life cycle management of blob is speaking about. So we have already known about the different tires, correct? The hot tire, cold tire, cool tire. So how this movement is happening, so that in order to save the cost is the life cycle here. That is the purpose of life cycle. So the movement of the blob between the different tires based on the criteria such as age or access pattern. Age means when it was created and when it was how frequently it is accessing. The access pattern, based on the access pattern, then the management of the blob, movement of the blob can be decided. So what is the purpose of it? It is mainly to optimize the data storage and the access cost, because obviously the data storage, that also would give you the cost. If you store the data in a hot tire, that would end up in a high storage cost, correct? So this life cycle, it will help you to optimize the data storage and the access cost. So you can define the different storage or access tiers based on the data age and the access frequency. So that is how you will be setting up the policy here. And it is achieved using lifecycle management policy. So what is lifecycle management policy? It is a set of rules how the blob data is moved between different storage tiers and the access tiers. So we'll be defining some criteria. For instance, if the file is so and so old, for instance, if the date of creation is 1 year before or 3 months before, then do something. So such types of policy you will be defining it here. So what are the parameters? It is such as access frequency, what is the data type, and what is the performance requirements that can be used to define these rules. And how the data, what rules do you define? How the data is moved between the different storage, whether you want to delete the blob or whether you want to delete the file in that blob or you want to move it to a different blob storage. So these are all the rules which we will be defining in the policy. So you can use the Azure portal or the PowerShell. All this you can use to create a lifecycle management policy. For instance, here I am moving the data to a cooler storage after a certain amount of time. Okay, for instance, this is where you will add a rule. Here I am adding a rule that move to the block after so and so particular time. And in the second picture, I have given you whether it has to move to the cold storage or the cold storage or the delete the blob. So for instance, if you want to store the data, then based on the accessible, the days which you will be accessing, whether you can either move to the cool storage or the cold storage. Or if you want to delete the data, if you think that the data is no more accessible after the certain amount of time, then you can also set to delete the data. And here you will be adding the rule. So in this case, when the rule is automatic, when the rule is created, the lifecycle management policy takes care of moving the file across the blobs or deleting. So that in that case, the storage account, the space is also managed properly and the cost is also optimized here. And that is the purpose of lifecycle management policy. The limitation of the policy here, the partial update of the policy is not supported. Only either it has to be a full update or it has to be no partial updates. Either it has to be a full update or the policy is only supported. And if the blob is encryption enabled, it cannot change the tier. So for instance, if you have enabled the encryption, it is also possible to enable the encryption in the blob, correct? So in that case, when you try to set the policy to move the tier, then it is not possible. Deletion is possible. And I think we have already told about the immutable container, where the worm, the right one. So that during that setup, the delete action is possible, because that is one feature where the modification and deletion is not possible for that particular blob, correct? So during this, the lifecycle management policy doesn't support on the immutable container. As soon as you create a policy, it takes 24 hours to take the effect on the first execution. So after that, that would be as usual in the proper speed. And if you have more objects in the blob, if the file size is more, in that case, the process might be slow. During when it is moving across the tiers or the deletion, during that, the process might be slow based on the number of objects or size of the blob here. Versioning. So as the name says, I think you would have guessed what is versioning. So you can also maintain the versions of the blob here. So automatically it maintains the previous version of an object. For instance, you have created a file and that will be the first version. So based on some setup, the versioning will be enabled and that will be your first version. And if you make any changes to that file, that becomes the previous version and the current modification becomes your current version. So the earlier versions of a blob to recover the data if it is modified or deleted. So even if you deleted when the version is enabled, and if it is deleted, even then it is possible to retrieve the file from that blob. So that is one advantage we have with the blob versioning. So whenever you modify, then a new version is created. It is followed by the version ID. So for instance, here you have a blob text, version ID 123. Okay, and you are making the changes to the version 3. And what happens? This becomes the fourth version. And it is also possible to promote the previous version as the current version. So for instance, you want to bring the version number 2 as the current version, then it is also possible to promote it. That is called as promoting. So this is one of the advantage of the blob versioning. And each write operation, it creates a blob in the blob creates a new version. That is what the versioning is, right? Whatever any changes, any deletion or any changes, it creates a new version here. And for the question comes here, what happens to the blob where the prior to the versioning is enabled? So here that is not possible. That doesn't have a version ID with it, correct? So in that case, as soon as you enable the version, that current version becomes the first version becomes your current version. So which is when whatever the changes you do prior to the versioning is not captured here. And if you delete without the version ID, it makes the current version as the previous version. So if you delete some version here, that becomes the previous version. So in that case, even deletion is also possible to retrieve here. Point in time restore. So here, since I am from a technical background, so I will be able to relate whatever features I have in my ERP. So all this I can correlate with the Azure Blob also. So you can take one particular blob to the stage where it was some 5 or 4 days ago or 10 days ago. So that point in time restore is also possible in the Azure Blob. So it restores one or more set of blobs to a previous state. So this is via this setup. There is a setup in the blob where it is possible to turn on the point in time restore. So what is the purpose of point in time restore? It protects against the accident deletion. So it will enable you to restore the blob data here. For instance, by mistake you have deleted something in the blob. So what can you, when this point in time restore is enabled, then it will take you to the version what you have asked. Let me take to the slide. Okay, so how do you bring it here? So you have an option called restore the selected containers, and you have an option to give the date when it has to take you back to that particular feature, particular version. So via this time, so for instance, today is 13th. So if you want to take that to 8th of November to that particular time, then that is also possible. So what happens, that restore, that this operation would take you to the blob in that particular, how the blob was there on 8th November, 11:15 a.m. So there will be only one restore at a time. So multiple restores are not possible. And if the blob has moved between the hot and cool tires in the period, then the blob is restored to the previous tire. So in that state, what was there during that moment, in that moment, it is there. And it works for both blobs and not for the append blobs here. Okay, so we have reached the end of the session. So just to recall what are the benefits of Azure Storage. So as you said, as you know now, you would have got an idea of what Azure Storage is and what are the features we have in the Azure Storage. So in a nutshell, I have given it here. It is durable and highly available. So with the redundancy options, whatever we have set in that Azure block, whatever Azure Storage account, it is possible to have that availability. So even if there is a power outage in your in the region or the data center, then there will be a seamless transition of whatever the data is being flowed to the user. It is secure because of the AAD access and the SAS token. The data is securely accessed and no unauthenticated calls is possible. It is scalable. So if you want to increase the storage account size, that is also possible. It is easily manageable because here you create the storage account. You don't need to worry about, in case of file shares, you don't need to worry about the operating systems, whether you need to patch or backup, nothing. It is easily manageable and it is easily accessible also, because via the HTTPS networking, it is possible to access the storage account as well. We have reached the end of the session. I hope the session was informative. Any questions? I have a question on the cost considerations. So here the cost consideration is based on so whenever there is any redundancy option set, you will obviously end up with some additional cost here.